So now that I've given you a brief introduction to the ImageStreamGang example, let's kind of talk a bit more about its structure and functionality, focusing on the combination of object-oriented and functional programming. So the overall design of this app uses object-oriented features in Java. And so you can see sort of at a glance what that means by looking at this. So we've got a whole bunch of classes, and these classes are related to each other by various associations, as they talk about in the Unified Modeling Language, UML. So we have things like inheritance, which are these arrows with the solid arrowhead. And then we have these implementations, which are the dashed arrows, and so on and so forth. We'll see different variants of these things. And the purpose of this discussion is to try to get across why object-oriented and functional programming work best when you combine them together, like peanut butter and chocolate. I actually ran into someone the other day who doesn't like the combination of peanut butter and chocolate. So I'll have to come up with a new metaphor to use, because obviously that doesn't encompass everybody. But maybe if you don't like peanut butter and chocolate, maybe like peanut butter and jelly or something like that. So whatever is your favorite combination of things. Of course, if you have a peanut allergy, then all bets are off. So my metaphor falls apart completely. So the classes that we have obviously apply many Java features to download and process images. There's a framework. Whenever you hear the word framework, you should sort of think object-oriented design, because frameworks work by defining abstract classes. So we have this thing called a StreamGang, which is an abstract class for being able to do a lot of different types of processing. And then we derive from it using object-oriented inheritance features to make an ImageStreamGang, which knows how to download and process images as opposed to some other kind of processing. And then we have a whole slew of different subclasses of ImageStreamGang that will process things sequentially, in parallel, completable futures. There's a couple of different completable future variants and so on. And all of this stuff just uses good old object-oriented design and programming features like inheritance. And the purpose of all this, of course, is to try to share fields, share methods, share structures so that you have more systematic reuse. That's the reason we use inheritance. And then within these things, we have different processing, which is done functionally. So image stream sequential, as the name implies, uses a sequential stream to download and filter the images. Image stream parallel, as the name implies, uses a parallel stream or parallel streams to download and filter images in parallel, concurrently. And then Java completable futures, all the stuff that say completable future, as the name implies, will download and filter images asynchronously using the completable futures framework. So the actual computations are done in a functional way, but it's in the context of an object-oriented design in order to emphasize commonality at the right point in the hierarchy. Likewise, we also have some other classes. There's an image class that provides metadata and methods for common image and file-related tasks for doing various kind of image processing and image transformation operations on images. And then we have this really cool hierarchy that applies the decorator pattern that defines how the filters are related to each other. So we have a filter class, and we have a couple of different types of filters. Here's a handful of them. There could be many more, of course. Null filter, which is just a no-op, grayscale filter. You could have, red eye removal filter, emboss filter, whatever your filters are. And then we have this other thing called a filter decorator that takes a filter and then will do the filtering and then store the results in the file system. So that's a really cool example of the decorator pattern. And then finally, we have a user interface for the Android app. So there's an Android version of all this stuff where we've got Android things like activities and image adapters and results activities and all these good things. And then there's also a console version of this thing that doesn't have a GUI per se. You just run it on the console like the command line. But it shares all of the other parts of the code. So 98% of the code is shared between Android and command line console version, which is also very useful because then you can get a lot of reuse systematically. Once again, a benefit of using patterns. Once again, benefit of using object-oriented design. So if we were to run this thing, and I won't run it for you, but you can download it and run it yourself. It's really cool. you'll see that when you run it, it'll prompt you for those inputs. You can give inputs, and then it'll go ahead and download everything. And there's some interesting results here. These tests were run on my 6-core Lenovo P52, which is got a lot of memory, 64 gigabytes of RAM. But honestly, it's only got 2.6 gigahertz. I actually have a quad-core machine that's got faster processors, but not as many cores. And it was kind of fun when I ran the test, because you can see for things like the sequential versions, the 4-core approach was actually faster because it's a faster processor. But for the ones that run in parallel, the 6-core ones were more scalable because it had extra cores. And so you can kind of see here, I have 2 different versions. So one will download a bunch of large images, and one downloads a bunch of smaller images. And there's probably 6 images in each one. And you can see here that the sequential version took about this much time to run, and the parallel streams one was faster. But notice in both cases, both for the bigger images and the smaller images, that parallel streams was not the fastest way to do things. And in fact, the completable futures version was substantially faster, or faster. Substantially faster in some cases, but it was definitely faster. And that's because the completable futures version is even more economical in its use of the processing resources on the underlying platform. And that's because it doesn't have to do some of the things that the parallel streams version has to do in order to obey the parallel streams semantics. So we'll talk, right now we're going to talk about parallel streams, but later, probably next week or the week after, we'll talk about the completable futures version. And it's really, really cool to compare and contrast them like that.